Hello, welcome to example 3 of TI portal ladder programming video. And in this example 3, we have counter as well as timers. It is a very good example where interlocking is used, timer, counter, and little bit of complexities also is there. It's more or less similar to what you can find in the real process, real factory automation or process automation. Such kind of logic you will have to face. So this is a very good example. If you can master this, you will understand the dynamics of ladder programming logic, how you can use different instructions to fulfill your logical requirements. It's a very simple, but yet it has many things to learn from. So let's go to the example. A process, is there, and that process can be started or stopped using a button. Start button to start the process and stop button to stop the process. This is simple. Now thing is, a certain process is to count number of true to false transition on input in count 1 for a 10-second period. So this process will count a input for 10-second periods. Now the counting is to occur if the input word 1 has a value less than 10,000 or greater than 20,000. So this is the condition. It's a kind of interlocking, you can say. It's restricting when to count that true to false transition of input in count. So this is one interlock we can say. And then 10-second counting period is to begin 15 seconds after the process starts. So the counting will not start immediately. Instead, when the operator will start the push button start, then it will count 15-second interval. After 15-second interval, there will be another time gap, 10-second period, and this 10-second period is there to count that true to false transition of input, the input in count 1. Now again I repeat, PStart is a process start input and PStop is a process stop input. The count display is to be output toward or 2 only at the end of count period, that is the 10-second period we said. All outputs to be de-energized 5 seconds after the count period. So you see three timers are there. First is 15 second, that is we will call it start delay, and then 10-second period, that is timer to count that input pulses to count the transition, and then after that 5-second more delay is there to de-energize the outputs. So this is like stop delay, you can say. The process should repeat only after another distinct press of the process start input. The same start input should be pressed again so that the process will restart the same way. Write an efficient ladder logic program for this process. So we need to write is efficient ladder logic. Ladder logic is efficient when it is simple and very easy to understand, and thing is that when you go online you can correlate between inputs and outputs, and also remember to name the variable as per their function, so that way you can also understand the story behind your logic. So we'll we'll break down the problem this way. We have actually done this list. We broke down the problem into few sentences like this. PStart will start the timer start delay for 15 seconds. So after this timer elapsed, timer count will run for 10 seconds, and during this count, this input shall be checked for true to false transitions. Counter 1 will be incremented for each transition. Counting is to occur if input word 1 has a value less than 10,000 or greater than 20,000. So this is again the interlocking instruction, and then after 10 second period elapsed, timer count okay, it has a 10-second period. Then timer stop delay. Actually, this stop delay is the process stop delay. Shall start for 5 seconds, and then word 2 shall display counter value. So counter value would be displayed before the 5 after the 10-second period timer has elapsed. After timer stop delay elapse, all timers counters shall be de-energized. These are the list of tags we need for the process. In count 1, which is DI pulse, PStart, PStop, two push buttons. We get these are actually normally open. Then counter timer count, the 10-second timer, and then 15-second start delay timer. Word 1 where we will check the value less than 10,000 or greater than 20,000, and then word 2 where after 10-second period timer elapsed, the value of count will be displayed. And then there is another timer, 5-second timer, and then counter 1. Counter 1 will be used during the 10-second timer. Now we have assumed some of the things, basic things. There is no physical output to be turned on and off in this process. We cannot find any description that says turn off any output, digital output or motor or valve or whatever. PStart and PStop are push button type input. These are the two assumptions we have right now. If you actually go details step by step, you can list some more assumptions. I guess we are not going in detail towards that. We are now focusing on writing the ladder logic, whatever we have with this information. So now let's go to the design of the software, how we're going to design the software. Here is the list. To write the ladder logic, we need to understand that we need some timers. Here we have 3 timers, so I will create 3 timers in the timers data block. And then we need one counter, and that counter we will create in counters data block. And we have few parameters like word 1 and word 2. This we have to save this information somewhere, so we create another process data block, and name of the tag table we will create example 3. Name of the watch table we will create example 3. Name of the function that contains example 3 ladder logic is also example 3, so that our software looks modularized and structured and easy to understand and correlate. So let's recap this. We have timers data block, process data, counters data block, and then function fc3, that is example 3, in which we have the whole ladder program. And then tag list. Let's open tag list. We have in count 1, which will be checked for true to false pulse, start push button and stop push button. This is the 3 digital input. We don't have any output in this ladder example. Let's open timer data block. The timer data block, we have 3 timers declared here. Timer start delay, And if you open this structure, we have 15-second predefined hard-coded time given preset time, and then timer count, that is second time 10-second timer, we have hard-coded time value 10 seconds, and then timer stop delay, that is after 10-second timer, this timer will be starting before actually resetting the whole timer and counter output. There is 5-second preset time, and then there is one counter. So with this counter one, we have IEC counter type, and we are going to use the up counter. For that we will use this input, and reset we have to use to set the count value. We will do that when the process is not running or stopped. Let's open the ladder program. This is interesting, and if you have followed my previous example 1 and 2, you will understand my software design in ladder logic. I do this first network to read the digital input and transfer the status into a data block memory location. Same thing I did here. 0. I0.7, 1.0 and 1.1, 3 inputs I have saved in data block all di. This is the all di db1. We have 3 variables. If I open this, so I have PStart, PStop and incount1, these 3 variables. And these 3 variables I used in the program to execute the remaining ladder logic instead of directly using this again and again. So I have now, let's do the first section of the problem. PStart will start timer start delay for 15 seconds. That 15-second timer will start when I press the start button. This is how we use for normally open push button. If I start this you consider this is a positive power rail. Power will flow through this. Now because stop button is not pressed, so this is, we considered stop button also NO type, so this is not pressed, so the power goes to this here, and this timer stop delay is not running at all, so we have status 0 here, and we have used the inverted NC contact ladder instruction, so the power goes up to here and the timer will start. This is 15-second timer, so immediately after we start press the start button, timer will start for 15 seconds. Now remember, when this is running, we have this coil also on. This is in the data block process data. So it's like process data, process running bit. And this bit we have used parallel to start button, because you know the start button is push button. It will be pressed and then released immediately. But our timer has to run for 15 seconds. To latch or seal this timer, we have to use this bit in parallel to start button, so that in case the start button is released, it will remain on for as long as these are not turned on. Okay, so now our process is running, timer is running, and once this 15-second timer is elapsed, this bit will get set. When this bit turned on, another timer, which is 10-second timer, will be running. So during this timer is running, at that time we have something to do here, and that is, sorry, so we have this check. I told you the interlock check. We have interlock check that process data word 1 should be greater than 20,000 or less than 10,000, and 10 second is not elapsed, that is for this one. And we have this in count 1, that we use here in count 1 is bit. In count 1 is check for positive pulse. Actually, we can check change to positive to negative as well. So it is check for positive to negative pulse. So positive to negative pulse we will increment the counter here, the counter we have used here. In case the process is not running or stop button is pressed, then the counter will get reset. This is very important logic that we should have this. Every time the process stops, counter must reset to 0 so that next time it will start fresh from 0. Now the 10-second timer has elapsed. The 10-second time, this is timer count. So this is all happening during this timer count is running within that 10 seconds. Once the 10 seconds is elapsed, we have this value, counter value, moved to process data dot word 2, and this will display the counter value. And then immediately after that 5 second, or you can say in same scan, the 5-second timer stop delay will start. And after that 5 second, we have used the counter 1 to reset. Even if we don't use this one, it doesn't matter. Actually, we can deal with this network because we have this, if process is not running, counter will get reset. So after this, because we have used this interlock in this network, and the process will actually break because it will set by this instruction. Once this bit set, this will get it will become a 0, and then if this becomes 0 and this here RL result of logic operation also gets 0, timer input actually will reset. The timer will stop and everything will collapse. So everything will shut down. The whole network will be shut down. So now that is the logic. Actually, it is expected that way. How we can confirm this logic is working? Let's test using a simulator. Okay, so for example 3, watch table. We have created a watch table. If you know this watch table, how to open, double click watch table. We have listed the variable we need to monitor and control, and let's this simulator is running. Now the start button will start the 15-second timer, that is start delay timer. Okay, let's start control F2. Okay, 15-second timer is running. Now we get ready with the input pulse. When 10-second timer will start, we will also change the pulse here, turn on and off. Okay, now turn on off, 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 off. Okay, so that is 9 pulse is cast. Now we have to actually stop this one, so it should not restart immediately after finishing one cycle. Let's do this again, few cycle. Okay, 3 cycle. Okay, 3 cycle. You see the 3 pulse is counted. So process stop this way. Now you start again, this one. Start again. Release the button. It goes back to false mode. When this timer starts, we will actually create a pulse here. Okay, start stop, start stop, start stop, start stop 4 times. So this will change to 4 now. 4. Now 5 second timer running, and it will shut down after 5 seconds. Yes, no, shut down. So this is working fine. Now one more thing is pending is stop button. We have not tested the stop button. So let's start again. It's running, and now press stop button when it's running. Okay, so the process stopped. So it's working now. Now one thing is pending here. If we give value 15,000, which is between two condition, it should not count any pulse. Let's start that one as well. This timer is running. During 10 seconds, any pulse, no pulse should be counted actually. Let's wait for that timer to start. Okay, give some pulse. No pulse should be counted. That's our understanding. Okay, just second, and see the pulse counted is 0. That means the logic is working fine. And let's we just recap what we did. We did ladder logic for a process where uh, pulse need to be counted when a timer for 10 seconds is running. The process will start using a start button. One 15-second timer will run, and once that timer finishes, another timer for 10 seconds will start. And during this run, we have a check that the value of one variable should be greater than 20,000 and less than 10,000, so that a pulse in count will be checked for positive to negative and incremented in another counter. So this is our main function for this process. So once this 10-second count timer finished, we start another timer, as well as we display the counter value in another variable. So after 5 seconds, this process will actually reset. The whole output counter, timer, everything will de-energized. That's the process. So hope it was interesting for you and you learned something new. And very excited to tell you that this logic can be simplified. And we have used so many blocks to do this small ladder logic. We have used how many blocks? We have used counter blocks, timer blocks, and process data. I will show how you can, compact this all ladder logic using function block. We have used this in FC3, that is function. This can be done within FB function block, which is a kind of a function with a data block attached to it, and that will be much easier understanding. We have so many data, distributed across 3 data block, and if we use the FB, we don't have to do this. All the data we can actually encapsulate into function block. I will do that another blog, another video, and create that FB and show you how we can do that. For this video, that is done, and hope you have enjoyed the video. Thank you, and see you in the next video.